All right, it's time to talk about the last piece of information we need to really describe a set of data, and that is outliers. Outliers are typically extreme values in our data set when compared to the rest of the data set. So it's important that we mention the comparing to the rest of the data set, because $1 million is extreme when all of the other data points are $10. $1 million isn't extreme if everybody else around that $1 million is also in the millions. So when we're talking about outliers, it's extreme values compared to the rest of the data set. And in order to compare something to the rest of the data set, I really need an idea of how spread out that data set is. So we've devised as statisticians 2 rules that we can use to decide whether something is an outlier. The first is called the 1.5 IQR rule. So this rule uses the interquartile range, or IQR, to decide if something is an outlier. So for the interquartile range, you obviously need the first and third quartile. You need to know what that quartile is. So you're going to calculate a lower bound based on our quartiles, and that lower bound is equal to the lower quartile Q1 minus 1.5 times the IQR. And remember, your IQR is Q3 minus Q1. You're then going to calculate an upper bound, which is the upper quartile Q3 plus 1.5 times the IQR. Anything that is less than your lower bound or greater than the upper bound is considered an outlier. Try that again. So for the IQR rule, these are distributions where we're using the mean and the interquartile range as our measure of center and spread. And we're looking at the edges of the box in our box plot, Q1 and Q3, and then we're going out 1.5 interquartile ranges outside of that box. And we're saying that's where we expect our data to end. Anything outside of that is too big or too small. The other rule that we can use is based on the other measure of spread that's really common, the standard deviation spread. And it looks a little bit different. So we have the 2SD rule, which is kind of what it sounds like. And it's a similar idea. We're going to calculate a lower bound. I'm not even going to write it out this time. I'm getting lazy. LB. We have an upper bound, and the rules are the same. If you're outside those bounds, you're an outlier. For the 2SD rule, our lower bound is the mean minus 2 times the standard deviation, and the upper bound is the mean plus 2 standard deviations. And again, the check is the same as it was before. Once you've found your boundaries, anything less than the lower bound, anything greater than the upper bound, those are your outliers. For this class, this guy is more common. But a reminder that in general, I'm looking at the median and interquartile range for skewed data. And I'm looking at the 2 standard deviation rule, mean and standard deviation, for symmetric data. The reason that the IQR rule is more common is that if I have a lot of outliers, even if my data is symmetric, I'd prefer to use the median and the interquartile range than the standard deviation rule. So by default, using that IQR rule makes more sense, because if I'm not sure if I have outliers, I probably shouldn't be looking at mean and standard deviation anyway. So by default, you'll see a lot of statisticians use that 1.5 IQR rule. I'd like to do an example really quick with you using that 1.5 IQR rule, and then we'll move on to our last little discussion. For example, we want to find any outliers in a data set using our 1.5 IQR rule. So slightly different data set than before. 1, 2, 2, 5, 8, 10, 10, 11, 20. And we want to figure out whether we have any outliers using the 1.5 IQR rule. So in order to use the 1.5 IQR rule, I need to know what my Q1 is, what my Q3 is, and what the IQR is. So Q1, Q3, IQR. Those are my first steps. Because this is a short list, I'm going to do it by hand really quick. So I cross those off, I cross those off, I got to do this. Let's just color code here. I'll do this first round in green. Cross off, 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 cross off. So we can see that our median is 8. And then I'll do the lower half. 8's not included. So cross off. I'm left with 2. So Q1 is 2. And then I'll do the same thing on the other side. 8 has already been used as my median, so cross off. I'm left with 10 and 11. So my quartile 3 is halfway between, which is 10.5. Which means my IQR is 10.5 minus 2, which should be 8.5. Oops, and I dropped my pen. Next thing we're going to do is we're going to calculate those lower and upper bounds. So lower bound for this data set is going to be Q1 minus 1.5 times the IQR. So for us, Q1 is 2 minus 1.5 times 8.5. And I'm going to do it on my calculator, but I can already tell that that is likely going to be lower than any of my data values. And my lowest data point is 1. So 2 minus 1.5 times 8.5. And that gives me negative 10.75. So I don't have any outliers on the low end of my data. My smallest data point is 1. So we're clear on that end. The real question looking at this data set is 20 an outlier? Because the rest of that data set's pretty close. 20's kind of out there. So let's check the upper bound. So upper bound is Q3 plus 1.5 times the IQR. So 10.5 plus 1.5 times 8.5. And I have a sneaking suspicion that's going to be bigger than 20, but let's check. 10.5 plus 1.5 times 8.5, and we get 23.25, which is just a little bit bigger than our largest value of 20. So there's no outliers on the upper end. So there's no outliers in this data set. All right, if you have any questions on how to use that 1.5 IQR rule, feel free to send me an email or catch me in office hours. Otherwise, I'll see you in the next video.